Okay, so I'm gonna do one example under energy on inclined plane. So you can calculate the energy based on inclined planes where you are given. This is the plane. So a plane is the surface where the object is resting or moving. So from here to here is the plane. Then it makes an angle of 30 degrees. So sometimes this statement can be given in words. So you must be able to sketch it. Now, this is a horizontal. This plane makes this angle with the horizontal. And from here above the horizontal, this will be the height. So you can never calculate potential energy if you don't have the height, because it's the energy of position by virtue of position. So this question says a car with a mass of 1,800, this is the object, is parked on an incline which makes an angle of 30 with the horizontal. The length of the slope is 2,500 meters. So this is the length of the slope. Now, students, they make mistakes in exam. They take this 2,500 and put it here and say it's the height, but it's for the slope. So if you sketch it, you will never make mistakes. Even if it's given in words, just sketch this thing. You're gonna see this one is the slope. Now, first question says, calculate the potential energy of the car at the top of the slope. So energy will be, is the energy a body has by virtue of its height. So one thing you must get first is what is this height? Potential energy formula is mgh. Yes. So I'm gonna show you how to do this thing. You are given the slope. It is 2,500, ne? 2,500 meters. And the angle is 30 degrees there. So you need the height in order to calculate the potential energy. So the formula of a potential energy is EP, which is equal to mg multiplied by the height. Now, M must be given in kilograms. Let's go back to the question so that we can see the value of M. The value of M is 1,600. And the distance is 2,500. So M is given. M is 1,600 kilograms. Now we need to get a potential energy. To get this potential energy, we are going to use the SOHCAHTOA maths. And we see which ratio fits in order to calculate this height. So which ratio can we use? This is opposite side over hypotenuse. Ne? So the ratio that fits is this one. Is the sine theta is opposite over hypotenuse. So you write it as sine of the theta is 30. It will be equal to the opposite side is the unknown. Ne? So you put h there divided by the hypotenuse is 2,500. Now you're going to give me the answers. You're going to use your calculator to get the answers. So you divide both sides by 1. When you cross multiply, this will be h equal to 2,500 sine of 30. What will be the answer? One to 50 meters. So we calculated the height. Now we can go back to the formula of potential energy and substitute. So it will be EP equal to mgh. Where there is m, you put 1,600. So this will be 1,600 and you multiply by 9.8 multiply by 1 to 50. And you use your calculator to get your answer. One 960000. That's all. Then units are in joules. In some questions, they can say calculate the potential energy in megajoules. So if you take your calculator, there is a button ENG just above 7 of your calculator. If you press that button, it's going to give the answer in engineering notation. So mega is 10 to the power 6. So when it displays an answer times 10 to the power 6, it means this answer will be in mega. So when you press that button, what answer is it giving you? It's 1 comma. Just press the ENG button. You have that answer of 19600, but just press ENG or divide by 10 to the power 6. You answer 1.96 megajoules. So a question can say, calculate potential energy generally. So it's correct even you leave it at this step. But if they specify in megajoules, this will be your answer in megajoules. If they specify in kilojoules, you divide by 1,000 and you get it in kilojoules. So this is how you do it. Let's look at the second question. Second question says, calculate the kinetic energy of the car at the bottom of the slope. If it runs down the slope, ignore any friction. So when the friction is neglected, it means a loss in potential will be there, gain in kinetic. There are no losses. There is no friction involved. So to calculate this, we use the law of conservation of energy. This law states that the EP on top, we had this total potential energy, right? So the EP loss will be equal to the EK gain. So the energy that has been lost is all of this one. So you just write there 1960000 joules equal to EK gain. That is your answer. So yes, even if you write this one is correct, you just say EK gain equal to 1.96 megajoules. So this is your answer. Energy that is lost on top is the kinetic that is gained at the bottom. So this question can also be asked this way. Let's say on top, when the height was 1 to 50 meters, is point A. But if it rolls down to point B, and the question says, calculate what is the kinetic energy at point B. Remember, at point A, it has this energy. But if it rolls down only to point B, what will be the energy at that point? So to calculate that energy, the EP, let's say this point will be 850 meters above the ground. So the potential or the kinetic, remember, if it's losing potential, that energy is not destroyed, but is converted to kinetic energy. So this question will be basically looking for what is that energy that has been lost coming from top to point B. So it means you must get what is the height there that has been lost, the height it traveled. Now let's first take it so that you can see. It will be EP loss or EP on top. It has potential energy at A. So if we can get the potential energy in A and potential at B, the difference between the two is going to give us what has been lost. Let's say at A, it has this 1.96 megajoules. At B, if we can calculate at B and we subtract B from A, we're going to get what is lost there coming from top. Now let me write a formula. That kinetic energy or that EK we are looking for will be equal to the potential EP at A minus EP at B. Remember, potential is the energy by virtue of the height. Now, height at A is bigger than the height at B. So this EK will be equal to potential energy is mgh at A. So let me put capital letter H since it is bigger, or we can call it H1 minus it will be mgh at B, or we can call it H2. We can call it H2 at B. Now, if at B is H2, you see M is common, M and G is common both sides. So this kinetic energy will be equal to, we factor out mg because it's common. And we're gonna open brackets. If we factor out mg, you are left with H here. So we can use capital letter H, or we can say it is H1. This side, when we factor out mg, you are left with H2, ne? Then it will be minus H2. So in other words, if an object is coming from the top and you are looking for the kinetic energy, you still calculate potential energy, but to make a difference between the height, because the height that you're supposed to use is of the distance covered, depending whether it was going up or going down. Potential it has here. But now if it's coming down, you need the difference. Just like a formula of V equal to square root 2gh, this h is always the distance covered by the object. So I'm gonna give you an activity so that you can see if you understand the concept I've just explained now.